Before proceeding in this fault category, it is important to ensure that the gearbox oil specification is correct. Use of the incorrect oil can cause the frictional characteristics of the gear clutches to alter, causing harsh engagement. It should also be noted that if the engine power is down substantially, this can again cause harsh engagement. Therefore, start the engine, engage D, and accelerate the engine to full throttle. It should achieve between 12 and 1400 RPM during the stall test. Assuming these initial items are in order, first ensure that the load sender is set correctly, as previously explained. If the test equipment is available, the voltage at idle and full throttle can be checked. Half a volt at idle, 4 volts full throttle. If the load sender is set correctly and the voltage readings are higher than recommended, measure the voltage from the control panel to the load sender, which should be 9 volts. Pins 2 and 4 of the load sender plug. If the voltage is higher, the panel is at fault. If correct, check the resistance of the load sender at terminal 16 and 35 on the panel plug, and the reading should vary between 1000 ohms and 400 ohms between idle and full throttle. If there is no reading, before replacing the load sender, check the resistance reading at the Cannon connector. Should there be a reading, there is a cable fault between the load sender and the panel. Referring to the original test, had the load sender been correct, a resistance check must be carried out on the throttle modulator solenoid and cable. N and U at the gearbox socket and 12 and 24 on the panel plug. The reading should be 8.3 ohms. If test equipment is available, install as previously described and set the selector switch to MOD. Switch on the ignition and select D. If the system is correct, a reading of 1 amp on the lower meter should be visible for approximately 1.5 seconds. If the output speed control is increased, this reading should occur at each gear change. If the throttle is moved down fully during this period, the reading will reduce to approximately ½ amp. It should be noted that if there is no reading, this does not necessarily mean that the control panel is at fault, because if the throttle modulator circuit is broken due to a fault in the solenoid or harness wiring, no current will be drawn. Therefore, it'll be necessary to conduct a resistance check on the throttle modulator solenoid and continuity tests on the harness before reaching a final conclusion. On the assumption the gearbox oil level and specification is correct, check the setting of the load sender and its electrical operation. Should these items be correct, check the oil pressure. If it's low, before suspecting a hydraulic failure in the gearbox, make sure that the oil filter and seals are serviceable. Should the main pressure be in order, check the throttle pressure at this point. At idle, the pressure should be approximately 6 bar with the selector in N and should drop to ½ bar for 1.5 seconds when moving the selector from N to D. If you do not get these readings, carry out checks on the modulator resistance and use the test equipment to check the panel function, as explained earlier in the program. Should the pressure be correct, the gearbox clutch plates are suspect. During this next section of the program, we'll be looking at the fault procedures to be carried out on the retarder system. Retarder, as discussed earlier in the program, is contained within the main gearbox and operates hydraulically. There are 2 levels of retardation available. Retarder controls can either be foot brake controlled or hand operated, or a combination of both if required. In this example, we'll be looking at a foot brake operated system. During normal operation, with the retarder off, air from the vehicle auxiliary tank at full working pressure of 8 bar is supplied to a pressure limiting valve set to reduce the pressure down to 3 bar. The air continues to an EP unit, which is in the closed position. However, the air can take the alternative path through a second limiting valve set to reduce the air from 3 bar down to 1.2 bar. The air passes through the EP unit and onto the retarder EP unit on the gearbox, which is known as MV1. During retarder operation, when the foot brake is initially operated, a micro switch signals the control panel electrically, and, providing the vehicle road speed is above 3 miles an hour, the panel will trigger the MV1 solenoid unit on the gearbox. This allows air at 1.2 bar to act on the hydraulic valve unit in the gearbox and allow oil to be directed into the retarder. The oil pressure within the retarder on stage 1 is approximately 2 bar. As the foot brake is depressed further, an air pressure switch located in the rear brake line is triggered when the pressure reaches 7 pounds per square inch. At this point, this EP, known as MV4, is energized, which now allows air through at 3 bar to the retarder valve. This increased air pressure enables a higher oil pressure to be supplied to the retarder unit at a pressure of approximately 4 bar. The pressure limiting valves and the MV4 solenoid are located in the following positions: on this cross member on the Tiger, on the engine bulkhead on the Olympian, and on the right-hand under-frame side member on the Lynx. The second stage pressure switch is in the front junction box on the Tiger, in the driving compartment on the Lynx, and close to the foot brake valve on the Olympian. In view of the slight differences in pressure switch operation on these 3 models, refer to the program fault diagnosis booklet for further information. If the retarder does not operate, you should first ensure that the oil level is correct and that the load sender is in order. It should be noted that if the load sender is indicating throttle, retarder operation is inhibited. If the retarder still fails to function, it may be a failure in any one of the following: the switch signal to the panel, the control panel, MV1 solenoid or wiring, air supply, or finally a hydraulic fault within the gearbox. To continue, first establish that there is an air supply to MV1. Next, connect a test gauge to the gearbox at this test point. Start the engine and supply 24 volts to the MV1 solenoid. Providing the solenoid is functioning, it should click, and a pressure reading of approximately 2 bar should register on the gauge. Next, press the foot brake down. If in order, the pressure should rise to 4 bar. If you do not get this response, the MV1 solenoid should be removed and checked electrically, and ensure that it passes air when energized. Should these tests be in order, there is a hydraulic fault in the gearbox. On the assumption the initial test on the MV1 solenoid was correct, you must check the continuity of the cable from the MV1 plug to the panel plug on pins 21 and 24. If correct, check that the panel is receiving the switch signal from the micro switch. This can be achieved on the panel plug connections 27 and 24 with the foot brake applied. No response would indicate a wiring or switch failure. If all these items are correct, the control panel is suspect. However, for positive identification, the test equipment must be installed. To do this, proceed as follows. Set the selector switch to AB. Switch the ignition on and select D. Turn the output speed control up until the RM light comes on. Operate the foot brake. This indicator light and also the retarder output light should come on. If no lights come on, operate this button, which replaces the switch signal from the foot brake. Should the lights come on, there is a fault in the switch or cable. Alternatively, if no lights are on, there is a panel failure. In this fault area, first inspect the MV4 solenoid and see if it clicks when the foot brake is applied. If it does, check the air pressure supply to the MV4 solenoid, which should be 3 bar. If not, check and adjust the limiting valve. The second stage retarder is triggered by an air pressure switch in the rear brake output line. Therefore, to establish if it's functioning, apply the foot brake and carry out a continuity test across the switch terminals. Next, carry out a resistance check on the MV4 solenoid and a cable check from the pressure switch to the solenoid. If no fault is found, the suspect area is the EP section of the MV4 solenoid. The first item to inspect is the oil level. If the oil level is too high, this causes excessive churning of the oil by the gearbox running train, resulting in high oil temperatures. In instances of very low oil level, the gearbox clutches and converter may be in a partial slip condition, again causing an increase in running temperature. High oil temperature may also be created by using oil of the incorrect specification and viscosity. On the assumption that these checks are in order, next disconnect the retarder electrical plug on MV1. If the overheating problem disappears, a check must be made on the retarder switch to ensure that it's not permanently closed. This can be achieved on the panel, plug pins 27 and 24. If incorrect, adjust the switch or replace if necessary. Before assuming a panel fault, finally check the cable between the switch and panel. Moving back to retarder operation, with the MV1 plug disconnected, connect the pressure gauge at this test point and start the engine. If there is a pressure reading, this means that the retarder operating valve or solenoid is stuck in the open position. In instances of no pressure reading, our next check is on the main oil pressure at this connection. You will recall that when the torque converter is in operation, the main oil pressure is at 18 bar, and when lockup takes place, the pressure drops to 10 bar. If the gearbox operates continuously with the converter unlocked, this will increase the operating temperature of the gearbox. On the assumption the correct pressure response takes place, the converter is operating correctly, and the main vehicle cooling system should be inspected. If there is no pressure difference, and the gearbox is running at 18 bar continuously, this is an indication that there is a control fault in the lockup clutch. Therefore, it will be necessary to carry out a resistance check on the lockup clutch solenoid on the gearbox socket pins H and N. And to check the cable for continuity, connect from H on the gearbox plug to 2 on the panel plug. It should be noted that the lockup clutch lockup point is controlled by the turbine sensor via the control panel. Therefore, a resistance check should be made on the T and M gearbox socket connections and at pins 6 and 25 on the panel plug to check the circuit. The next stage is to use the special test equipment if available. Set this control to T. Start the engine and check this lower meter for a speed signal. If there is no reading, the air gap on the sensor may be set too wide. Should the reading be correct, supply 24 volts to the lock-up solenoid, and if it clicks, the panel is at fault. In order to carry out an oil and filter change, the transmission should be at normal working temperature. The drain plug is located here. To gain access to the filter, remove this cover plate and withdraw the filter element. Next, remove the suction tube. Replace this O-ring and lubricate with oil, and then push the suction tube back firmly into position. Ensure that the O-ring in the replacement filter is in position. Replace the filter and push into position. Replace the O-ring in the end cover, and again lubricate with oil. Replace the end cover and ensure that the bolts are tightened with a torque wrench to avoid damage to the gearbox. To refill the gearbox with oil, initially add 2.6 gallons. Start the engine and add a further 1.1 gallons, pouring slowly. The oil level, if correct, should be between these two marks. To complete the refill procedure, bring the gearbox to the normal working temperature of approximately 80 degrees centigrade. With the engine at idle, the oil level, if correct, should be between these two marks. This final procedure is known as a hot check and is the only accurate method to establish the precise oil level and should therefore be used at all times. If it's necessary to change or check the turbine sensor unit, you'll be required to remove these securing screws. And remove the sump. Next, unscrew this plug. This will now give access to the sensor. Remove the sensor wires unscrew the sensor. Take care not to lose the shim washers. The running clearance and setting procedure from this point are identical to those conducted on the output sensor covered earlier in this program. Should you require to replace a gear solenoid, this valve block must be removed. To do this, first remove the harness plug by releasing these two screws. Next, disconnect the output turbine sensor wiring. Remove all the retaining set screws, with the exception of these 6 smaller screws. The shift valve block can then be removed. Contained in the valve block are all the shift control valves and solenoids. Located at this end and looking from left to right are the solenoids for B, E, and D clutches. And here for A, C, lock-up clutch, and F clutches. This is the throttle modulation solenoid. And finally, the turbine sensor. The hydraulic shift valves are located under these cover plates. When replacing the valve block, ensure that the sensor wire is not trapped, and remember to use a torque wrench to tighten the retaining bolts on the valve block and sump. It is vital when carrying out any work on the gearbox that every precaution is taken to avoid dirt entering any part of the gearbox or hydraulic system. Failure to observe this recommendation may result in gearbox failure or a series of intermittent faults. In instances of vehicle breakdown, when the fault is within the control panel, an emergency link can be installed which bypasses the control system and allows direct selection of second and reverse gear. It should be noted that if it's necessary to tow the vehicle, there is a speed limit of 20 to 25 kilometers per hour, and the towing period should not exceed 2 hours. This towing procedure should only be carried out providing the oil level is correct in the gearbox and no mechanical defect is suspected. Should any doubt exist, either the axle shafts or prop shaft must be removed. Failure to follow this recommendation will result in serious damage to the gearbox. During this program, we've attempted to show the fault procedures that can be carried out using basic test procedures. There will inevitably be situations where it'll be necessary to call upon the use of the special test equipment. With any fault diagnosis procedure, always follow a logical path. When a fault occurs, you must ask yourself, is the control panel receiving the correct input signal? Is the control panel sending the correct signal to the gearbox? Is the signal arriving at the gearbox? Are the gearbox solenoids operating correctly? To avoid unnecessary breakdowns, remember the importance of the load sender settings. Use only recommended oil. Maintain the correct oil level, and carry out oil and filter changes at the specified periods. If you're in any doubt as to the procedures contained in this program, you must seek further advice, and remember the recommended safety precautions when carrying out fault finding, repairs, or adjustments.